So as we go across a row, and this is my beautiful picture of a periodic table here, as we go across a row, what happens is that the ionization energy actually increases, and we can think about logically why it is that that's happening. As we go across a row, what we have happening is that the Z, or the atomic charge, I'm not talking about Z effective here, I'm just talking about Z. The Z is increasing as we go across a row. That's easy to see. But we're still in the same shell. So we still have the same n value as we go all the way across a row in the periodic table. So in general, what we're going to see is that what happens to Z effective if we have Z increasing, but we're in the same shell here. Would it increase or decrease Z effective? All right, kind of a mixed thoughts here. So it turns out that it increases, and the reason is because the predominant thing that's going on here is that the Z is increasing. So the Z is increasing, and what goes along with it is that the Z effective is increasing, because it turns out that while we're in the same n, even though we know that energy depends on both the n and the L in terms of quantum numbers, while we're in the same n, the distance from the nucleus, it's pretty close. It's not hugely different. So the factor that predominates is that we're actually increasing Z. That's why we see Z effective increase, and that's why we see ionization energy increase. As we go down a column, what happens is that the ionization energy decreases. We can also think about this in terms of Z effective. This is because even though Z, the atomic number, is still increasing, we are also getting further away from the nucleus. So remember, when we talk about Coulomb force, what's holding the nucleus and the electron together, there's two things we need to think about. The first is the Z effective, or how much charge is actually in the nucleus that's felt, or I guess we would say the Z, how much the charge is on the nucleus that holds it close together. But the second factor is how far away we are from the nucleus. So if we're really close to the nucleus, that's when Z effective is high. But if we get really far away, then Z effective is going to get low, because even though we have the same charge in the nucleus, the Z effective gets lower. So this is not even thinking about the other electron shielding. Just if we think of the fact, all we need to think about is that the effect of going to a further away n actually dominates as we go down the table. We're getting further away from the nucleus because we're jumping, for example, from the n equals 2 to the n equals 3 shell, or from the n equals 3 to the n equals 4 shell. And when you're switching n's, you're actually getting quite a bit farther away.